All right, so a second example of solving quadratic equations using the zero factor property. Let's just remember real quick from last time, we had we didn't have this one, but something like this. And we need to get it into standard form first. Remember, standard form is ax squared plus bx plus c equals 0. Well, this isn't it is a quadratic equation because it has a squared on it, but it is not in standard form because it's not equal to 0. So I'm going to add 12p to both sides. So p squared plus 12p equals 0. And now I'm going to just look at this part, pretend the equals 0 doesn't exist, and just go through my factoring rules. Is there any greatest common factor? Well, yes, there is. P, that leaves me with p plus 12 equals 0. Now I have two factors. It's fully factored, so I'll set each factor equal to 0. P equals 0. And p plus 12 equals 0. Well, this guy is already solved. Nothing more to do. Here I just need to subtract 12 from both sides, and I get this. And so my final answer is p equals negative 12 or 0. Let's just think about this. We don't need to physically check it, but if we do this real quick, what's 0 squared? Well, 0 squared is 0. And what's negative 12 times 0? Well, negative 12 times 0 is 0. So does 0 equal 0? Yes, that means 0 is an answer. Let's try this one. Negative 12 times negative 12, that's negative 12 squared. Negative times a negative is a positive. And 12 times 12 is 144. And then on this side, negative 12 times negative 12, negative times negative is a positive, 12 times 12 is 144. So 144 equals 144 means both of these answers are correct. Now, let's go on and do some from rule number 3a and b. So this is our next example here. We have a plus 6, a minus 2 equals 2 plus a minus 10. Well, this does not look anything like ax squared plus bx plus c equals 0. So I have a lot of work to do before I can get it into standard form. So first thing I'm going to do is go ahead and on this side of the equal sign, I'm going to multiply these out. Foiling, as most of us know it. So a times a is a squared. A times negative 2 is negative 2a. 6 times a is plus 6a. And positive 6 times negative 2 is negative 12. On this side, I have this and this are like terms, so I'm going to combine those. And that's negative 8 plus a. Now, I need it to be 0 on this side, so here is my squared term. I always want to put everything where he is, and I want to keep him positive. So if he was negative here, I would move everything onto the right side. But because he's here, he's the only one, and he's positive, I'm going to move these two over to the other side. Actually, I'm going to unmess this up. Maybe. Okay, let's just do a big eraser. Well, there we go. Just isn't wanting to work for me now. All right, well, forget that. Anyway, I'm going to, oh, now it works. 2a, 6a. I'm going to combine those two terms because they are like terms. That gives me plus 4a minus 12, just because it makes solving an equation easier if all my like terms are combined on each side separately. Now I am going to go ahead and add the 8 and subtract the a to get everything on the left side, only because, again, this a squared is positive over here. So a squared, and I like to keep everything positive whenever possible, or the most important things. So when I subtract a from 4a, I get 3a. And when I add 8 to negative 12, I get negative 4. Now, I did all that just so I could get it into standard form, and now I'm ready to start the problem. Okay? So, I have to ask myself, rule number 1, is there any greatest common factor? Well, there is not. So, rule number 2, is it a special factoring form? Again, we're just going to say no for right now. And rule number 3, is it a trinomial? Well, it is. Here's a squared is one term, 3a is a second term, and negative 4 is a third term. So it is. Let's go with 3a then. Rule 3a. Because this is a 1 coefficient, so we're going to start with a double bubble. Remember again, it's rule 3a. That is the only one that we start with a double bubble. None of the others we ever start with a double bubble. And I'm going to put an a in the front of each one, and then 1 times 4 equals 4, and all my factors of 4, and it looks like I need this one, and that would have to be a negative 1 and a positive, 4. Sorry about that, guys. So let's just double check. When I add these two together, negative 1 plus 4, I get a positive 3. And now remember, last critical step, multiply just your signs. Negative times a positive is a negative, and that's what this is. So we're ready to go. I can take these and just plop them in here. And now I have two factors, and so I can just set each factor equal to 0 and solve. So here I'm going to add a 1 to each side. Here I'm going to subtract a 4, and so I get a equals negative 4 or 1. Let's just check these real quick. Let's start by checking. Now remember, we have to check in the original equation. Okay? So I'm going to put negative 4 everywhere I have an a. So negative 4 plus 6 and negative 4 minus 2 equals 2 minus 4 minus 10. And now, because we're checking, we never ever go across the equal sign. We just do all the calculations on one side and all the calculations on the other side until we get down to the end. So in here I've got 2, and remember these are being multiplied together, so times, these are being added, but these are being multiplied together. And then these are just all being added. So 2 minus 4 is negative 2 minus 10. 2 times negative 6 is negative 12, and negative 2 times minus negative 10 is negative 12. It means that negative 4 is correct. Now let's check 1 and do the same thing. So we've got negative 1 plus 6, it is positive 1. Sorry about that. Let's get rid of him. Well, maybe. Okay. And back to here. Okay, so 1 plus 6, 1 minus 2 equals 2 plus 1 minus 10. Okay? Again, inside here we're just adding, so that's 7. But remember, these two are being multiplied, so that's negative 1 equals 3 minus 10. 7 times negative 1 is negative 7, and 3 minus 10 is negative 7. It means that these answers are correct. Okay? And let's do one more. Is this our third example, I think? Yeah, let's write it in. 3. We've got 3n to the third plus n squared equals 4n. Now again, this has to be in standard form, ax squared plus bx plus c equals 0. So, first thing we're going to do, again, this guy is our biggest exponent, and he's positive. This term is positive, so we want him to be positive, so let's just move this guy to the other side. We'll subtract the 4n. So we've got 3n to the third plus n squared minus 4n equals 0. Now, rule number 1, any greatest common factors. Well, yeah, I can get an n out, and that leaves me with 3n squared plus n minus 4 equals 0. Now, just looking at the rest of it, because I already did rule number 1, rule number 2, is it a special factoring form? It is not, and we aren't going to go through all that. We've already done that in a different video. Rule number 3, it is a trinomial, but this has not a 1 coefficient. So remember, we take the 3 times the 4, and it equals 12. And let's find all the factors of 12. So 1 times 12, 2 times 6, 3 times 4. And I need it to be a 1, so I think it's going to be this. Should be negative 3 plus 4. So add these two together, I get a positive 1. That works. Last critical step, multiply just your signs. Negative times a positive is a negative, and that's what this is. And so we're good to go. So now I'm going to rewrite this stretching my middle term. So I got 3n squared minus 3n plus 4n minus 4 equals 0. Now I just need to factor these by grouping. So I'm going to factor these two. Remember to keep that n on the outside. Do not lose him. He's very important. So I can factor a 3n out of both of these. That leaves me with n minus 1. Remember, just bring down whatever this sign is. So that's a positive. I can factor out of 4. That leaves me with n minus 1 equals 0. Let's finish factoring this guy. These are our greatest common factors. So n minus 1 comes out front. And what's left here? 3n plus 4 equals 0. And now I've got 3 factors, and because this was a 3, I expect 3 answers. If it's a 2, I expect 2 answers. If it's a 4, I expect 4 answers. Unless it's a perfect square trinomial. If it is a perfect square trinomial, then I expect 1 less answer. So if it's 3 and I end up with a perfect square trinomial, I will expect only 2 answers. So n equals 0, n minus 1 equals 0, and 3n plus 4 equals 0, n equals 1, 3n equals negative 4, n equals negative 4 thirds, and so n equals negative 4 thirds, or 0, or 1, and there's my answer.